Hello, everyone. We are live. Welcome to another community call with Memgraph. I'm glad to see so many of you registered and joined today, but it's no wonder since we have an interesting topic today. Today with me, I have our CTO of Memgraph, Marko Budiselic. It's a special call today because it's one of the three upcoming calls we're going to have with Memgraph folks. So right now we are in the middle of launching a lot of new exciting stuff within our AI toolkit. Today, Marco will talk about turning unstructured data into knowledge graphs and the tools you might need for that. Tomorrow on the next call, my colleague Ante will talk about migrating your data from a SQL database to the graph database using our newly built agent. And the next Wednesday, our colleague Tony will talk about NPC client in Memgraph Lab. So if you haven't already, make sure to sign up to those community calls as well. I'll post a link to both events in the chat so you have that there as well. Now, without further ado, I hope you enjoyed today's presentation and demo. And as always, we have a chat here, so feel free to chat with each other or ask any questions you might have during the presentation. And we're going to have a Q&A session at the end of the call, and Marco will answer all of your questions. We also have polls available, so feel free to cast your vote there as well. Now I'll stop talking and I'm going to let Marco take over. Enjoy the presentation, everybody.
Hello, everyone. I hope you all hear me. Mattea, let me know if it doesn't.
Yeah, we can hear you.
Yeah, welcome, everyone. Nice to see you all. There is a bunch of people here, so that's great. I'll try to share my screen now. Give me a second. Entire screen. Share. So I hope it's visible. Yeah.
Yeah, it is.
Slideshow. Yeah. Anyway, welcome again. This is talk about Unstructured2Graph and AI Toolkit. Basically, it's the first one in our series, so I'll try to give my best to explain what we worked so far and our experience with Unstructured2Graph mostly. First of all, for those who don't know me, I'm Marco, CTO and co-founder at Memgraph, mostly in charge of the product and figuring out how to make the best out of Memgraph and how to help all our users and enterprise customers the most. It's getting super interesting because there is a bunch of different use cases and a bunch of different applications there which can leverage Graph, and it's really interesting. So quickly, agenda. I'll briefly mention about Memgraph. Then the obvious question is why anything and why now? There is obviously a bunch of unstructured data out there, and the question is like, why is all that relevant? Then I'll quickly introduce AI Toolkit because that's a big and important piece in the whole Memgraph ecosystem, having a bunch of stuff there. Then a few words about challenges with turning unstructured data into a graph. There is like plenty of them, so we'll go through that. And then like in an important, let's say, design principle, building on top of giants, because there is already a bunch of tools available and people are doing some really interesting libraries which can be used and leveraged to do a bunch of tasks. And then I have a quick demo as well, basically focusing how the process of unstructured data to graph looks like, and through the lab there is also nice visualization, so hopefully that's going to be interesting. And also, once you have the data in the graph, the question is how do you query, and there is also interesting approach there. And yeah, quick wrap up in the end. So first of all, briefly about Memgraph. So for those who are not super aware, Memgraph is in-memory high-performance graph database, but also in the recent, let's say, years, it's used as a context engine for the AI, basically powering all the retrieval and memory layers and all the applications in the AI stack. In terms of why anything and why now, I think everyone agrees that AI is the future, and people are basically using LLMs and all other machine learning / AI tools to actually extract data and fetch underlying insights. But in our experience, LLMs are not enough because they are really good at general and public knowledge. But the challenge is when there is the whole enterprise context and a bunch of private data. First of all, LLMs are not trained to do that. They have the context window issue, and also there is a bunch of security concerns people are concerned about. Companies are starting using RAG a lot. Almost everyone is doing some kind of a RAG there, RAG meaning retrieval augmented generation. But still, there is a lot of challenges there, mostly with accuracy, hallucination, and also it's very like the whole pipeline should be super custom, while current pipelines are mostly based on vector search, which is good in certain cases, but it fails in many other cases. So that's the reason why there is a GraphRAG, because it's actually a combination of regular search mechanisms, let's say text search or more general vector search. But yeah, when it comes to like what happens after that, you actually need like a deeper provenance on the data, like compliance with different things, and grounding of the data based on the knowledge graphs. Basically, this is like a quick visualization of what is usually considered as a GraphRAG. Basically, when a user or question comes in, usually some kind of a pivot search is done. That can be like vector search or text search or any type of search to actually find entry points in the data. And then there is the relevance expansion part, which is usually running some graph algorithm like BFS, DFS, or shortest path, or basically you can plug in many different mechanisms there to actually search for relevant data. And once there is actually one step further. Once you have fetched all the relevant data, you also want to order that and rank the final documents, and that's also like part of the GraphRAG. Also, when I talk about GraphRAG, I also mentioned like text to cipher approaches, which for a given prompt generate graph query, or for example, query focused summarization, which was published by Microsoft Research, which is basically answering questions, answering like broader questions about the data set, and based on these community detections and figuring out like how to summarize like communities of topics. And then what's the actual state right now? There is a bunch of unstructured data. According to Gartner, 80 to 90% of data is actually unstructured, and it's growing faster than the structured one. So there will be just more of that data as we go further. These are basically all the documents, emails, different transcripts, basically any type of document data or video or anything you can imagine goes into that bucket. But what's important there, all of that data is having a lot of enterprise or institutional knowledge, different rules, different risks, or different explanation about different processes, and that's all kind of hidden in the underlying data. And basically, the goal is to figure out how to extract all of that data, turn that into a knowledge graph, and then build pipelines to actually efficiently retrieve the data. Now, like going a bit further, so what we did a few years ago actually is we started doing something called AI Toolkit, which is a repository on GitHub, which has a bunch of tools where the goal is to help developers and building all these pipelines and AI applications in a faster way. It's just a centralized location where we store all the code, and we try to iterate as much as possible, figure out different building blocks. And yeah, we actually publish different libraries on the repositories like PyPy and others. But yeah, on GitHub we have one place where actually we put all the code, or we try to centralize the code, because then there is a bigger transparency in what is available and what's not. You can also think of a toolkit as LLM facing API. So basically, whatever interfaces with LLM is there. Basically, from Memgraph perspective, like we're trying to integrate different LLMs in the Memgraph ecosystem as best as possible. So far, we have a few interesting components. So there is Unstructured2Graph, which I'll talk a bit more during this talk. And there is also a SQL2Graph agent. Ante will talk more about that, I think, tomorrow. And there are also various integrations. Probably most important one is the MCP, Model Context Protocol, because that's getting the standard. That's becoming a de facto standard in querying different data sources and then plug that into an LLMs. Basically, you can think of it as the USB for LLMs. But yeah, in the AI toolkit, there are different integrations with MCP stack. And then various other tools like different connectors, different evals. That's also one of the topics we're going to talk in the future, because in the GraphRAG pipelines, evals are super important. Basically, evaluating the final response can also be very specific. So in addition to existing tools, in a given application, you should probably think about application-specific eval so that you can drive the quality of the answers higher. So let's finally get to the unstructured data and AI. So the challenges there are various, and because the whole process of taking data is not straightforward, basically you have, I kind of split that into two buckets, like smaller challenges and bigger ones. So smaller ones are basically a lot of existing code is pretty hard coded. So you have one pipeline, one type of pipeline, or at most a few pipelines, which take the data. And then if you want to tweak something, it's pretty hard. You can't actually do that easily. We have to break the whole library apart and figure out your own code to do a custom pipeline. Then a lot of the tools out there are actually reinventing the wheel, meaning that they re-implement what is already implemented. I'll mention two cases in this presentation, but basically we are trying to leverage the existing open source libraries because people already built a bunch of good stuff and a bunch of problems are solved. But the challenge is then how to actually integrate that in the best way. And also one point is that ontology, or the schema of the whole graph, is not known ahead of time. So and then oftentimes you have to define the ontology upfront, but that's kind of not great because you don't know about what is in that data in the first place. So the system should be able to process the data and give you the ontology out of the box. And yeah, that's an important part, to actually figure out how to model the data based on, I know, the data set you have, and also it's dependent on the questions. So for example, if there is like some very specific questions, maybe text decipher is the best way, but then you have a certain schema. Or if you ask broad questions, then like these communities are important, and then the graph model is different. And we are trying to, that Ante will also talk about that a bit more. We are trying to tackle that approach automatically as well. And then there are a few bigger challenges. The processing of data itself is very complex because there are different languages included, a bunch of ambiguity, different style of writing. For example, it's totally not the same if you are processing some, like, I don't know, day-to-day language type of document versus some very complex accounting or a legal document, because these sentences are often super large and very hard to figure out what's subject, what's predicate, what object, and that type of thing. So it varies on the actual content of the data. And then, I mean, ultimately, the biggest challenges are cost and time, because it takes a lot of time to actually process data in a high quality way. Basically, LLMs are by far the best in processing the unstructured data, in my opinion, but the challenges are the time and the cost, because it takes, I know how many tokens, I know how many compute power to actually process the data. Yeah, and these are like some of the challenges we are trying to solve, but yeah, ultimately it's complex thing. And then maybe a bit more specifically how we do this. So as I said, we are trying to leverage existing tools. For example, the first one is the unstructured library, which basically does the first part in the whole pipeline of taking unstructured data. It's basically chunking of the whole thing. So taking anything and turn that into chunks. That library, maybe you are aware of it, but it has a bunch of different options. Basically, you can parse like 30 different types of documents, and there is a huge support for various different data types. And yeah, it's basically just we plug that in. We are trying to configure it in the best possible way and leverage what it offers. What's maybe one important point which I haven't seen much out there is that chunks are kind of dependent on those documents. So for example, if you have a Word or PDF document, that's usually a bunch of paragraphs, like sequential paragraphs. And ideally, you want those chunks to be exact paragraphs, because that one paragraph has some unit of meaning there, and it's very coherent. So you want to chunk by paragraph. But for example, if you take into account like CSV or some JSON document, that's like completely different thing. So that has a completely different meaning for a chunk. So anyway, my point is just that you have to take into account how the data is actually structured under the hood, and then make the most out of that. Then going forward, so once there is the chunking done, the question is how do we extract entities and relationships from the document. And then we found LightRAG as being very good library to do that. So it's essentially just, you can think of it as like a very nice a tool that has a bunch of system prompts, prompting LLMs in many different steps to actually extract entities and relationships from the document. And basically, we try to do like some simpler approaches because LLMs are expensive, but quality on, for example, legal documents is amazing with LightRAG. So definitely you should do that in terms of extracting entities in the slightly more complex case. What we added in addition, we actually, once we chunk the documents, we actually link those chunks, these semantically important chunks from the document, we link those to entities. So, or we link entities to those chunks. And that's like a part of the Unstructured2Graph library. So basically, you can actually, you have an optionality to query those entities directly, or you can search for those chunks and then search for connected chunks through the entities. Yeah, basically, I think I mentioned everything here. And then the demo time. So I actually have a demo of all of that. Let me just, yeah, now I'm back there. Let me go first under the cursor. So I have here a quick code, basically showcasing the whole GraphRAG pipeline. Yeah, maybe the first point is probably what I'll try to ingest. I'll try to ingest our recent documentation from GitHub documentation repository, because that's not part of any LLM like learning, and it's not LLMs. Public LLMs are not aware of it currently because we didn't yet merge it. It's just the documentation which is part of the recent release. And basically, this is a bit of utility function to actually initialize LightRAG and Memgraph and do the cleanup, basically just for the purposes of this demo. But what's important is this like from unstructured function. Basically, on that has to be called on top of the sources. And again, sources are just this is you can just specify a bunch of different sources, HTTP or directly local files or whatever you have. And then there are a few options which are not that critical at the moment to explain, but basically all these sources are taken taken and parsed, chunked, and then entities are extracted, and there is a graph out of all of that. So once that's done, I'm also here. I didn't talk much about that, but I compute. Basically, I'm doing GraphRAG in a way that first vector search is done, and then we run BFS. So for the vector search part, we need to calculate embeddings. And for that, we are actually using, so here I'm using Memgraph image, which has support for embeddings. That's part of the Mage image. And it's actually, so you can run these embeddings are also part of the ingestion challenge. Because if you have a bunch of chunks, you have to compute those embeddings in an efficient way. And then if you have like, I don't know, millions of chunks, which is not that high, so you can have that easily, then you probably need GPU to calculate the embeddings. Yeah, these are basically just embeddings on top of the whole chunk. And anyway, once these embeddings are computed, we create the vector search index for it. These are just, so this is actually all done inside Memgraph. So Memgraph has the procedures to run these sentence embeddings and also vector search. There is a vector search index built in, so you can index those vectors. And once that's done, now we came to the probably the most interesting part in terms of a GraphRAG. So and here I would like to introduce another concept. Basically, we call it one query GraphRAG. The idea is to actually have one declarative query where you can express the whole GraphRAG logic instead of having like a Python script which combines all these steps and you have something in the end. But in the meantime, you have to figure out a bunch of error handling and composability and stuff like that. But instead of that, there is actually, you can write query like this one, which will take the prompt, calculate embeddings. And yeah, important thing is that basically these vector search embeddings should be the same as the one for the prompt, all the config. And that's also one of the things, because Memgraph has the config for all of that, so you can reuse that one. And anyway, once that's done, you have embeddings, and then you can call vector search with those embeddings, and this will yield the most relevant, the most similar nodes. And once that's done, from those nodes, we are expanding using BFS to like some connected chunks. So from the chunks we ingested through entities which are coming from those chunks, we are searching for connected chunks which are there. And once we find those chunks, we have to do some kind of on ordering, and to do that we use just simple degree function currently, just the number of edges on a given node. But here you can use like PageRank or community detection score or something which is more appropriate. Probably PageRank is the best if you want to find most impactful nodes in a graph. And yeah, basically that's it. So this is the GraphRAG part done in a single query. Once that's done, this is just like the rest here is just assembling all of that and sending to an LLM to GPT-4o just to summarize all the thing and give the answer. There is somewhere there is system prompt. Basically, I just quickly build that. So I just build a system prompt, which is super simple. Your helpful assistant to answer the questions based on the context. And let me show you. So here I have that's also visible. So I'll actually let's get back to the first the ingestion. So I'll run this script with the ingestion flag. So basically it reads those chunks from the migration guide we added, and there are 13 chunks based on that document. And now those chunks are already stored in Memgraph, and now we are extracting entities. So I'll go into lab, and as you can see here, a lab is getting data in. And if I execute the query, no, there is a small glitch here. I'll just... So as you can see, of course, live demo always fails. Something actually failed. Let me rerun the demo. Yeah, here you can see the chunks. So basically these are here. Not sure how it's visible. But yeah, these are the texts here. And each chunk is linked to the previous one. That's also part of the ingestion. And then, as you can see here, like as we go along, these entities are getting in, and they are linked to the chunks there. So yeah, now import is working, so which is good. So as you can see here, there is more data coming in. So chunks are basically those chunks coming from unstructured, and then those base labeled nodes are extracted entities from LightRAG. So this is actually very nice because, for example, you have, concept is label matching semantics refers to rules governing how labels are matched. So LightRAG actually figures out the semantic meaning of that entity. And yeah, basically now the ingestion is happening. This is just like a nice visualization to actually see how it goes. One important thing is that I think actually this is how GraphRAG should be done, basically in an interactive way. So you kind of build your pipeline, but you want to run the data in parallel and ingest data as much as interactively as possible. So because it's going to take some time to process the whole graph and figure out the best possible prompts and everything, and you want to play with it and experiment as you go. I should have probably made that a bit bigger. Yeah. So that's it. This is now ingesting. I think it needs to process these chunks. One also important part is that basically processing of the chunk on, let's say, my average setup takes like a few, let's say 10 seconds per chunk. So it takes quite a while to process process chunks. Of course, that can be parallelized and like improved. But one important thing is with constructing the graph is also that you want to be aware of how long the whole process will take. So as soon as this first document is finished, the Unstructured2Graph will actually give an estimate how long it will take for the rest of the chunks to complete. Yeah, this is actually happening right now. So the code processed 13 chunks and 40 is left. So I added another document which is Parquet documentation, and that's another feature we are working on, load Parquet. And that one is a bit bigger documentation change, and that has, I don't know, like 20 plus chunks currently, and this is processed, but it will take like approximately 6 minutes to parse all of that and build the graph. And if we go back here, so I'll run this, and this graph is now getting, it's a bit messy here. These chunks are connected through entities, so this is getting bigger and bigger. And yeah, it will take some time. But while that is importing, I hope this is going to work because in the code, let me just answer that question. So the question was, the question we are trying to answer is what is different under v3.7 compared to 3.6, because that's not part of the public documentation yet. and just in parallel, I'll run this GraphRAG without ingestion. So while the stuff is getting ingested, we'll try to answer that question. Yeah, vector is already created, so that's fine. I hope this is gonna fly. Yeah, so as you can see here, for that question, what is different under WIP 3.7? We changed the way how label-based authorization works. Basically, instead of having some dependencies, hierarchical rules, we have flat privileges now. That's one of the things. But yeah, it's actually, this answer seems to be correct from the whole thing. And if you ask like LLM is totally not aware of it because it's very specific to our current release, which is super, which this essentially got merged a few days ago. So anyway, that's it. While this is getting loaded, I think, yeah, it's working. So let's get back to the presentation. That's basically it on the demo side. And yeah, just to make an overview. So what I showcased here, we have like, here is the architectural diagram of the whole pipeline, but basically I showcased mostly unstructured data into a graph. For example, those entity extraction and chunking. That's what is done under the demo. Once we have the graph, we are actually running. We can, because in the one query GraphRAG, you can run different pivot searches and relevance expansion, vector search, text search, or like different graph traversals. And yeah, I haven't touched at all about agentic frameworks, but that's also gonna come in a few weeks. We're gonna talk more about MCP and other things there. Oh, sorry. This is that's the reference architecture, and then quick call to action for developers. Feel free to try it out. You can like spin up Memgraph using Docker and install Unstructured2Graph. It's a Python library, so yeah, pip. You can use pip or UV or whatever is the package manager of choice. Or maybe probably even easier is to run that in the cloud. That's also available. Feel free to have fun on that side. And also for enterprises, so we actually have a GraphRAG Jumpstart program. Basically, we are trying to offer help with building all these GraphRAG pipelines. So far, we did actually a few of those POCs, and I think all of them were quite successful. So if you have like 2 weeks of time and your data, happy to give expertise and help you accelerate that. Please register on memgraph.com/GraphRAG. That's basically the web for that. And yeah, if you have any questions, please reach out directly to me or join our community on Discord. And basically, that's it. Thank you for listening. I hope it was fun.
Yeah, this was great, Marco. I'm already quite familiar with the topic, but it was really interesting to listen to it from the user perspective. Okay, let me just move you next to me. We have a lot of the questions from the community, so we can start answering those and hopefully answer them all in time.
Yeah.
But first question is, this was at the beginning of your presentation when you just started talking about it, but how about RDF and the reasoning?
RDF and the reasoning. So yeah, it's always an interesting question with RDF. I think so. We are completely, I know, label property based. So we don't have many like RDF based tools. I think RDF and the label property graph is super like interchangeable thing. Basically, you have a graph representation of something and then you query it. Of course, like you always have these ontology reasoning and different rules you can extract and define. But I think that's also my opinion is that that's all possible to do under both systems. So kind of it's very interchangeable. Of course, RDF is more like tilted towards those reasoning use cases and yeah, specific ontology extraction and stuff like that. but the same is possible under LPG. That's my opinion, but yeah.
Yeah.
Not sure if I answered, but yeah, feel free to. Now I see the problem is that during the presentation I didn't see these comments, so now I can see them. So if you have a follow-up question or something, please do.
Yeah, until that, we have another question. So these were when you started with the demo, so it's most related to that. But the next question is, how do you contextualize the chunks? Do you need to use the complete document to contextualize the chunk, and is it costly and slow?
So yeah, the question is, what does contextualization mean? So I think that's not part of the current solution to add some meaning or the context for the whole document. So that's not part of currently, but that's a good question. I think that's also something we might add. For example, we should add a document node and then link that document node to all the chunks and then put some context in that document node. I think that's totally doable, and it shouldn't have all these problems from graph theory like supernode, because document is not usually there is no like document wouldn't have millions of chunks. So from the modeling perspective, that should be fine. But yeah, how to figure out the context, I think that might be challenging, because you might need to analyze the whole document. I mean, analyzing a single chunk is already too expensive, if you ask me. So in all these research, I try to come up with the fastest way of analyzing chunks and the most high quality way. And then the fastest ways are really bad in quality. So you can parse a chunk in, I don't know, like a few milliseconds, but the quality of those parsing is very bad. And then like parsing a chunk with LightRAG, LightRAG is actually executing a few of those LLM calls for each chunk. That takes, I don't know, with ChatGPT, I mean, I didn't use the whole, I don't have access to like premium platform or something, like it's not the best probably infrastructure, but it takes like 10 seconds to process one single chunk. And then for a document, I know that cost and time can go massively high. And also problem is the context, because you can put probably like smaller documents in the context, but if you put like hundreds of pages into LLM context, that's not going to work. So like it's going to be super hallucinated. So yeah, but yeah, figuring out the context is probably hard for the whole document, if I got the question right. But yeah, one idea is from the SQL2Graph. Ante will probably talk more about that. These attributes. So already, I mean, you probably don't know a lot about the whole document, because document has a bunch of knowledge, but you can probably build, as an organization, you can probably build like a summary of that document, or like somehow have a pipeline for that. And then once you have that, you can include that in the whole thing. But anyway, like from the perspective of library, that's another pipeline and processing stage there.
Yeah. And one more related to processing. So how do you specify what kind of entities are extracted from the chunks?
Yeah, that's the point with a schema. We don't. So because you don't know what is there, I think LightRAG, what LightRAG does, LightRAG extract these entities as a concept level. So it tries to find the most important entities and then explain what are those and make connections between them. And that's how it works. But I mean, there is probably a few classes of entity graphs and extraction there. So that's done by system prompt. So and I think LightRAG, you can tweak LightRAG to actually change the system prompt and then do something else instead. But yeah, that's a bit on the LightRAG side, and figuring out how to actually plug those in. But yeah, for sure, like if you use LLM to extract entities and relationships, then the system prompts are the way to go to actually specify how to do the entity extraction.
Yeah. And I just saw a similar one. Let me find it. So a similar question, do you define an ontology first and use it as a reference for extracting chunks?
No, I think I'm super opinionated there. So I think that shouldn't be done in upfront because you don't know what you have in the documents. I mean, if you knew, you would probably build that in the first place. I mean, if you know, then great. Then you don't need to run all the extraction. In my opinion, of course, you can define some classes, but that also, I think, for these large documents, like for example, if you have public filings of companies, these are hundreds of pages of documents. You can't define all the entity classes there. I think you have to build a system that will actually recognize and tune that system instead of manually defining the entities. And again, like it's just entities itself. I understand like the schema itself is important, but again, that schema is large because usually when you leave a LightRAG there, you end up with a bunch of, over time you end up with a bunch of extracted entities, and you don't know for them for sure.
Yeah. And the user asked, what if you have a fairly large document catalog, say Word files, and already have processed these documents for a range of keywords? Can you embed these text chunks together with these keywords?
Yes, so that's exactly the point. So that's why I think it's super important to have the chunk, because the chunk in this approach is actually uh, like specific for the given domain. So for example, if you have like a bunch of legal documents, you have those paragraphs there, and those will get extracted. But then you can also, because you know what are those chunks, basically chunks are these paragraphs, you can attach keywords to those chunks as well. With traditional libraries, they just do chunking by some limit, or like by some number of words or something. But that approach is problematic because you introduce a lot of noise and you cut all the domain knowledge. Kinda, you randomly cut the whole thing in pieces, and then you can't. I mean, you can still attach keywords, but there is no meaning to the whole thing. It kind of got shuffled around, more or less.
And what if you
But
have
yeah,
to
again,
introduce?
there is
Yeah,
also
sorry.
like chunk size has to be controlled, so you can't just put anything. Like for example, if you put a page, the whole page under a chunk, that's, for example, most embedding algorithms um work work with a very specific limits in terms of input size. So basically that's like 300 to 800 of tokens. So, and that's like the page is way bigger than that. So what's going to happen in the vector search case, you're going to get the whole page will get I mean, the, let's say, half of the page will be truncated, and that thing won't get into consideration at all. So we want to be aware of the limits. It's actually dependent on the way how do you calculate embeddings, what are chunk sizes. So you have to have that aligned to make the most use of the whole thing.
Yeah, and what I wanted to ask is, what if you want to introduce some new documents to the existing one? How does that work?
Yeah, so basically the unstructured is there to parse anything. So currently we just use chunking from unstructured, and that works for different document types. It works in a different way. So we didn't introduce any specific chunking yet, but like unstructured does that. But for specific rules, you can plug in specific rules for specific documents, and you can like tweak for a given document type what do you actually want. But yeah, currently it's whatever unstructured does. But for example, for document, for Word document and PDF, that's like paragraph is the chunk.
Yeah. And one user asked, is it important to include chunk embeddings in knowledge graph or GraphRAG? And if yes, should the embedding be stored as a property of the chunk node or as a separate linked node?
Sorry, is it important to include chunk embeddings in a knowledge graph? Or yes, should embedding be stored as a... I mean, um, so you need embeddings somewhere for sure, because you want to search for them. Of course, if you do text search, then you don't need embeddings necessarily. But let's assume we use vector search for the initial pivot search. You need embeddings. what we are currently working on is maybe just a detour a bit. So we are working on the advanced vector search feature where those embeddings will be stored only on index, inside index. So it won't be, we won't have those on properties, on the nodes, and also in the index. So we're going to have single storage for those embeddings. But if you want to perform search, you need those embeddings for sure. I think it's possible to have another node and link it, but I don't see a reason for that. Why would do that? Why would you do that? Maybe there is some specific case, but I don't understand the use case now. But anyway, I think like if you want to do vector search, and that's required when you want to do those semantic searches and when you don't know exact keywords and you want to find those relationships, like when the text search doesn't work the best, then you need vector search, and when you need vector search, then you need embeddings, and then you need index for that. So that this is all like chain of dependencies there.
Yeah, and if something's unclear with the answer, or maybe you meant something different,
Yeah.
feel free to post it in the chat and we're going to clear that up. But yeah, one user said that in a typical company, not everyone has access to all documents, and how can we control or propagate access rules on the graph?
That's a good point. So we saw that like firsthand. So yes, that's why you need those. That's exactly why we are implementing these. Basically, the data set I showed, the label-based authorization. So you need label-based authorization for that. But yeah, the question is, how do you actually? What is the actual access control rule? So here we only have chunks. But I guess you have to define different chunks. So class chunk A, or label chunk A, chunk B, chunk C, and then you define access control rules. So you can see only those. So chunk A documents will only come from, chunk A will only come from like a certain set of documents which certain people have access to, and then you have to define the access control rules in the graph. So anyway, that's like doable. I would do that through different labels, but again, this is exactly the point. So in this case, you need to build a pipeline for that. So you need to actually define those in a pipeline and have all these access control rules, because you want to create different label chunks and then having those there. So that's custom thing, and that's what most of the current libraries and frameworks are not covering at all. You have to build like rules there.
Yeah, I'm going to send over the link to our role-based access control so you can see how that's actually done within Memgraph.
It's actually so like, it's just we are changing it because we are making it much more powerful. So it's whatever you sent, it's probably changed. It's going to be probably changed in next week when we release the feature. But yeah, it's there.
So stay tuned.
Yeah.
Yeah, let me just send the links because I cannot multitask. But yeah, so another question we have is, does Memgraph come bundled with VectorDB? And if not, where are the embeddings stored in the demo?
We don't have embedded VectorDB, but we have embedded, a vector search library there called usearch. We did, when we implemented vector search, we did research what is the best. And because Memgraph is in C++, there is a bunch of C++ libraries, which is very nice, but usearch seems to be the best fit for our use cases. Essentially, the answer is, I mean, yes, because we have the built-in vector search capability. It's not done by another DB. It's actually that library, but it fits nicely with our stack. And again, what we are currently doing, because the biggest problem with databases is that you usually have primary storage and index storage, because you have to copy the values which are stored. But then for text search and for vector search, these values are huge. For example, those vectors take, I don't know, 300 elements, or that's actually the smallest one. Like 384 is the smallest number of elements there. You can have thousands of elements there, especially, for example, if you're encoding video content. So video content is much bigger embeddings size. And then what we're going to do, we're going to implement, we're going to store those embeddings only under index. So essentially cutting memory usage in half. And yeah, another issue is that with the vector search, you probably want to do it in memory because of those vector search is done super efficiently in memory. So you won't actually have enough. You want to have enough memory to support it. But if you copy everything twice, that's like double the size. So yeah, we are trying to we're gonna release that probably during December. The advanced vector search, which only stores data in one place. Currently, like you can run vector search and stuff, but data is copied twice. That's the current implementation.
Yeah. Do you think that refining Memgraph schema after a first run and then using it with LightRAG in a second run will enhance the knowledge graph?
Yes. So I haven't showcased this in the demo, but what also quick announcement is that we are working on something called HyGym, hypothetical graph modeling. So definitely the schema should be refined as you go because different prompts and different like basically different prompts require probably different schema, and you want to alter the schema based on the system usage as well. But usually people come with, let's say, a few dozen at most of those queries, but in production you have much more queries and prompts executed, and you want to tweak it. How exactly? I think you need some optimization function that will tell you, oh, this model performs better on this type of questions, or like for 80% of the questions you have, this model is better. But the idea is to over time build those uh, build support for hypothetical graph modeling, where you actually put some hypotheses into place and then try to evaluate the graph based on the system inputs. But yeah, specifically about on a length chain, I'm not sure, but probably probably there is something you can actually use um, to alter the schema and improve the schema. But yeah, happy to feel free to reach out. I'm super interested in that topic in general because I think it's impossible to get the schema right for all the cases. Because when you're developing system, it's impossible to get the schema right for all the production and the deployment queries because you don't know the queries. So for sure that has to be iterated over time.
Yeah. And for the next question, we have a long one. So when building RDF ontologies, I'm able to reference open source foundational ontologies to ensure that I'm not reinventing the wheel by recreating business logic that has previously been well-defined and validated. Is this type of capability available with Memgraph? So I know that the entire question is not available on screen, but you can read it in the Q&A section.
On Q&A, sorry, I want to answer when building RDF. Yeah, I mean, that part, if you have ontology defined, that's like, I would say, trivial case. You just take that into account as well. But yeah, where is the, sorry, yeah, I'm not sure. I don't see the second part of the question, but I guess like if you have ontology already defined, that's like amazing. So then just go for it. But I mean, um, I don't think LightRAG does that out of the box. But I think once you have the ontology, I think that's basically, I think in that case, you can even use like simpler methods to actually extract stuff from existing documents. So I think that's slightly simpler case than totally unstructured, because usually people come up, oh, I have those documents and I don't have anything else. And then like, what do you do? But with ontology defined, that's a much better case.
Yeah. And I think we answered most of the questions. Let me just check if I missed anything. We have some questions regarding the tech stack and the pipeline we use. So I sent the link to the AI toolkit, and there you can see the code and everything is available there as well. And we'll have this recording available on Memgraph's on-demand page. So I'm going to send the link to that over as well. So you're going to have that there available in a day or two. So keep an eye there if you want to rewatch the recording. But I think we answered all of the questions we currently have in the Q&A. If anybody has any other question, let us know. But yeah, maybe we have 5 minutes to spare. So I wanted to ask you, I was there present with the building process of this, and I'm quite familiar with that. But I was wondering from your engineering perspective, what was the biggest challenge you had while building this and the biggest challenge you wanted to solve?
So I
I know
think
it's painful.
the biggest challenge was, I think, like I expected to be able to write something which runs faster and more cost efficiently than LLMs, but it's hard. So LLMs are really good at extracting entities, basically orders of magnitude better than what you can write. And of course, I didn't spend probably enough time to implement the right pipeline. For example, I used spicy and libraries like that, even some of dedicated sentence transformers. But like models like ChatGPT and like bigger models are extremely good at extracting entities. So basically, engineering that part was the hard part, and I didn't actually succeed to build something which is better than LLM. And then if that, let's assume that's the truth, then the question is how do you run those LLMs as fast as possible? And then you end up in all the GPU stuff and a lot of infrastructure to actually run LLMs very cost efficiently and fast. And that's
Yeah.
engineering challenge itself. But I think that's one thing, and that's very well defined. But also the challenge is to figure out the exact schema and ontology for a given document, because anything can come in, and then the question is how do you do that? But that's, I think, a slightly smaller problem, because you have, whoever is developing the pipeline has to figure out how to actually extract those entities and is the ontology right, and verify all of that, evals. That's not that hard of a problem, but it's hard work. So it requires a lot of effort to actually get the right extraction and deduplication and all the stuff there.
Yeah, and I also think that that depends on the end user and the use case and what does the user actually want from their data set and what do they want to extract later on. So yeah, but I mean, there always has to be room for improvement. So there has to be some challenges.
Um,
But we
I think
have
there
one
is
more
another.
question.
Yeah.
Yeah.
Yeah. I just noticed. Yeah.
Yeah. So the question is, how can I add agentic chunking with LightRAG and integrate with Memgraph?
Um, I guess agentic chunking. Yeah. It's not yet. So what I showcased, it's not yet agentic. So just a disclaimer. So or maybe off topic. Ante will show agentic sequel to graph. I think tomorrow. Is that tomorrow?
Yeah.
Yeah.
Tomorrow.
So that's totally agentic, and that's like much better. Much more interactive in terms of the whole process. So current process is not that agentic, but it could be like the whole process of defining what is a chunk and document you have. For example, you can send a sample, like one, for example, from sources of documents. You can use unstructured to actually try to parse those documents, and then you learn what's there, and then you can have an agent which will actually guide you through the best process and the best chunking. And we're gonna add that. So like under Unstructured2Graph, that will become an agent which will iteratively try to help with the right chunking, and then integration with LightRAG. Probably also, like, I mean, LightRAG is nice, but there are probably other ways. For example, if LLM is too expensive, you should probably pick something else other than LightRAG. But yeah, there should be an agent which will take any document, figure out the right chunking, and then integrate with the right tool, let's say LightRAG. Because LightRAG, for example, API is very simple. So it gets the document and it gives you back the entities, and that's it. It has some other functionalities. You can also put any document. It doesn't have to be already processed, but I think in that case, I think you want to be in control of what's chunking and what's entity extraction. These are like very important parts. So if that's the case, then you have to figure out your own um, chunking strategy, and that's where agentic is coming in.
Yeah, and I guess we have room for one more question. So
I have
the
time. I have time.
question
So
is just one more. The question is, what are the minimum and recommended requirements to run an on-prem instance? So how many cores does Memgraph utilize?
So I mean, it depends what exactly are you planning to run. So Memgraph is very lightweight. So Memgraph itself needs just like, I don't know, a few megabytes of memory to run. Basically, minimum requirement is like, let's say, a gigabyte of RAM to be available, so that can store like smaller graphs easily. And then how many core? So Memgraph, that's one. So Memgraph community doesn't have any limitation in terms of compute. So you can run Memgraph on any number of cores. Usually, number of cores is correlated with the amount of memory. So you need to have, I don't know how many cores on the machine to actually plug it in. But Memgraph can leverage all of that. So however many cores you have, that can be leveraged. And again, that's part of the community. So community doesn't have limitation there. Probably the best, like I think I checked the statistics recently, but let's say 30% of our users are using ARM. So if you want to maximize the compute power on Memgraph, probably the best is to run ARM machines because they have higher number of cores per memory. So yeah, try out that. Memgraph works on ARM as well. So try to run it there. If and it's ARM is usually these days everyone wants to compete with x86. So cloud providers have a bunch of ARM machines which are much cheaper. Let's say half the price. So it's much cheaper to run ARM as well. But yeah, in terms of running all that pipeline on-prem, that's a bit more challenging because all the embeddings and all of that part, that's relatively easy because it depends on open source models and basically CPU or GPU. GPU is much better. So if you have on-prem GPU, that's much better, much faster to calculate embeddings. Let's say 100 times. It can be 100 times faster than a CPU. But again, that's easy to run on-prem. When it gets tricky are those LLMs because big LLM providers like ChatGPT are very high quality compared to local models. Basically, I think the distance between quality of public models or open source models and the private ones is growing, at least on the west side of the society. So if you apparently there are some really good open source Chinese models which are very high quality and can be run on-prem. So that's, I think, the way to go if you really want to run everything on-prem with high quality. But I haven't tried. I tried LightRAG with ChatGPT hosted model, but also locally. So I run ChatGPT 20B open source model locally, and that works. That's okay. That can be easily run. I actually had like two GPUs running locally, and then running 20B OSS model from OpenAI. Anyway, like you can build the whole pipeline on-prem for sure. But yeah, these are like Memgraph itself, then embeddings, then the LLM. All of that has to be somehow configured on-prem. And I'm 100% sure it's possible, but it requires a bit more work.
All right. I think that's all the questions we had, and we already went past our time limit, but that's all right. We have to answer all our curious users. But thank you again, Marco. This was great. I really enjoyed the presentation. I hope everybody else did as well. The recording will be available on our on-demand page. I already sent the link to that in the chat. So in case anybody missed anything or you want to rewatch something, yeah, thank you for joining us. And as we already said a few times, we have few upcoming calls. So one is tomorrow, one is next Wednesday, and then few of them coming up as well. So stay tuned for all of that. But thank you everybody for joining. I hope you have a great rest of the day, and I'll see you all tomorrow. Bye.
Thank you all. Take care. Bye-bye.